All right, we are going to start out Unit 2 talking about functions, and more specifically function notation, which is a way of expressing a relationship between two variables. Functions have inputs and outputs. More frequently, you see a function written as f of x, which is really read with what I just said, f of x. And in function notation, f of x, the whole thing is your output. Or you can think of it as a fancy way of saying y. I like to write out, just as a reminder, f of x is equal to y, okay? That's a good thing to remember as you're working through it. Where f is just represent function. We don't always use f. We could use g, h, any letter can represent a function. It's just a way that we name them. Your x value, since it is a function, is your input. That's your x value. And the part on the right side of the equation is the expression that we will either be inputting a number into, or we will be setting it equal, and then that means we will be solving, depending on whether we are giving an input or an output. And again, one more time, the input is the x value. So if you plug a number in for x, that means you've got to plug it into the expression side for x. If you're given a whole f of x is equal to something, that means you have the output and your job is to find x. X and y always go together. So if we look at it this way, and again, I just wrote it up at the top, but one way to remember this is f of x is equal to y. A coordinate point, if we want to write it, a coordinate point is the point x comma y. So function notation just simply means that the x value is 3 and the y value is 7. If you input 3, you get out 7. So it's a little bit easier than it looks. If you input 2, you get out 18. That's the point 2 comma 18, and so on and so forth, because f of x is another way of saying y. It represents an entire output. So now if we start actually evaluating and finding values, now I'm plugging in numbers into a function. That is just the same thing as inputting a value, or evaluating is what we call it in math. So you'll need a Desmos or you'll need a calculator so that you can actually calculate these things, okay? So if you notice, I am talking about function g for this one. And you have an example up there, but I'm talking about function g, so I need to be looking at function g. And what I'm doing for function g is it's telling me to find g of 2. So in function g, which is 4x plus 1, instead of x, I am going to input a 2. I can put this in my calculator, or I can throw it into Desmos, and it should get me out -8 plus 1, which is -7. So we can write it as g of 2 is equal to -7, which we can also write as a point 2 comma -7. Then the next one, we are going to not do the g function. Oh, didn't mean to erase that. Now we're going to be looking at the f function. Okay, so if I'm looking at the f function, now my job is to plug in 9 anywhere that I see x here. So f of 9 just means that 5 times 9 minus 3. Plug this into Desmos or into your calculator, either way, depending on what you have. So f of 9, is equal to 42. Or we can represent this as the point. If I input a 9, that's the x value, I get out 42. And we keep going. Again, g of 1/2 means I'm going back to the g function that I've highlighted in purple. G of 1/2, which we do not like fractions, means -4 has to be multiplied by 1/2 and add 1. Plug it into Desmos or plug it into your calculator. Half of -4 is -2, plus 1 should give me -1. So if I put in, which is okay, you can do fractions, this would be a point 1/2 comma -1 if I put this on a graph. And then last one, it says f, so I'm looking at my green function, so I'm going to change colors. F of 0 is equal to 5 times 0 minus 3. Put this part into my calculator, so f of 0, 5 times 0 is 0, 0 minus 3 is -3. You don't have to write it as a point, but I'm just showing you that it is still represented as a coordinate point like we did above, 0, comma, -3. So now flip over to page 3. We're going to do the same kind of situation, except for I'm going to jump over. I'm just going to show 1 or 2 of these, but same thing. If you put in a number for x, you've got to put it into x in the equation. So we're using this g, right? So it means g of 4 is equal to -4 times 4 plus 1. So that's the g. I highlighted too much. That's the g of 4 part, okay? And now we're taking this whole part and adding 1. So we have an extra 1 that we have to add at the end. And our final answer would get us out. -4 times 4 is -16 plus 2. -16 plus 2 would give you out -14. Okay, so that would be what we get out if we do this. I'll do one more of these. F of x, so f of 3 means that I'm taking the f function. I'm going to not write f of 3. I'm running out of space. So there's the f function. I plugged in 3, but I still have to subtract 4. Put all of that in Desmos. 5 times 3 is 15. 15 minus 7, because we're subtracting all of that. 15 minus 7 would give me 8. Okay, so that is how we do if we're given an input. Now, we gave you an example, but what if we're given the output, meaning we're given what the whole entire function is equal to? Okay, so in that case, if we're trying to find x, I'm going to go ahead and highlight some key words here that we know of. If we are finding for x, you have to solve, okay? When you have to find something in math, that means you're solving. So these are some examples down here at the bottom. Number 13, -4x plus 1, and they told me that g of x is equal to 18. So if g of x is equal to 18, I've got to plug in, instead of g of x, I'm going to put in 18, bring down the function. Now I can solve for x, and I can use my solving skills to get my input. We're going the opposite way this time. Subtract 1. It's not a pretty answer. So x is equal to -17/4, which is okay. We can get an ugly answer. So now we can kind of work it backwards. If I want to write it as a coordinate point, the x value is what we just solved for, and we were given the output of 18. Okay, so if you see the function is equal to a number, that means you have to replace the entire function and solve. So they told me f of x in number 14 is equal to 22. So I've got to take this expression 5x minus 3 and set it equal to 22 and solve for x. This one's going to work out a little bit prettier and give me 25 is equal to 5x. Divide by 5, and x is equal to 5. Okay, so we found x. If we want to write this situation as a point, x was 5, and the output that they gave me that I had to set it equal to was 22. That's how I write this answer as an ordered pair. So now you're going to move over to your homework. and you are going to work on your homework on this function notation